Lessons in Logic, video number 14, I believe, and we've just finished our introductory unit. So now we are beginning our next unit on categorical logic. Let's, at the risk of some redundancy, overview a few things briefly that we've already talked about before, but which you have to have fresh in your mind to begin a unit on categorical logic. Logic is the study of methods for determining whether the premises of an argument provide good enough support for their conclusion. A valid argument is, well, valid is a technical term in the study of logic, and a valid argument is one in which it's not possible for the premises to be true and the conclusion false at the same time. And validity depends on form, not content. In other words, it depends entirely on the pattern of reasoning used by an argument and not on what the argument is about, or it depends on the way we reason about things, not the things we reason about. There are some ways of reasoning about things that make an argument valid, that mean that if the premises are true, the conclusion has to be true. And there are other ways of reasoning that do not do that. If an argument is valid, then its validity depends entirely on the way of reasoning and not at all on what the argument is actually about, which means that deductive logic, which is the study of methods for determining whether an argument is valid or not, deductive logic is concerned entirely with the way we reason about things, or it's concerned entirely with an argument's pattern or structure, or to use the usual language, is concerned with the form of an argument, not its content. And that means we need strategies, we need skills, we need tools for identifying the form or the pattern of an argument, for figuring out what's the way an argument reasons about things. And that means we want to reduce an argument, and reduce is maybe not the right word, reduce an argument to its form. But let me see if I can say this differently. I don't really like how I just said that. We want to take the content of an argument out and just look at the structure of reasoning that the argument uses. So we want to break down an argument into its smallest parts and look at the relationship of those parts in order to figure out what is the pattern of reasoning used by the argument. And that's how we test it for validity. So there are two basic approaches to deductive logic, and there are more advanced approaches that we're not likely ever to cover in this playlist. The two basic approaches to deductive logic are, one, categorical logic, and two, statement logic. In statement logic, we break down an argument into its smallest statements and the relationships among them. So in statement logic, we symbolize the small statements of an argument, and then everything else that's not part of the structure of an argument, maybe was there for rhetorical reasons, well, we definitely take that away. But also everything else that is part of the argument, well, we keep there, but it's just ways of putting statements together. In other words, let me illustrate. Argument, if it is raining, then the ground is wet. If the ground is wet, then I should be careful because my old shoes don't have much friction on them anymore. Therefore, if it is raining, then I should be careful because my old shoes don't have much friction on them anymore. So, actually, I don't like that. Let's do that again. If it's raining, then the ground is wet. If the ground is wet, then if my old shoes don't have much friction anymore, then I should be careful. Therefore, if it is raining, then if my old shoes don't have much friction anymore, then I should be careful. My old shoes don't have much friction anymore. Therefore, if it is raining, then I should be careful. There, that's a good argument. So that argument has, I think, the structure if X then Y. Now I need more variables. Let me go back. If W then X, if X then, if Y then Z, Y, therefore, if X then Z. That's the structure of the argument. And in statement logic, we learn tools for first representing the structure of the argument by breaking it down into all its if, then, and, or, not kind of things. And just looking at those things plus the statements, but not considering the content of the statements in the argument, just looking at the statements as individual units. and looking at how the argument puts those units together. That's statement logic. And then we learn tools for testing arguments to see if the premises guarantee the conclusion once we've identified the structure of the argument in this way. None of that is anything to do with this video or indeed this next unit of the course. This is just me spending a little too much time over reviewing some basic concepts again. In categorical logic, we do something similar, but with terms rather than statements. In categorical logic, we look at the structure of an argument by considering its terms. We break an argument down into its constituent terms and the connections among them, and then we look at the structure of the argument. Now, a term is a noun or a noun phrase that stands for a class of things, or a category of things, or a group of things. So in categorical logic, what we do is we break down an argument into its constituent categories, and more precisely into the terms representing those categories. And then we look at the relationship among those terms, among the premises and conclusion, to see if the argument is set up in such a way that the premises guarantee the truth of the conclusion. That is to say, if the premises are true, the conclusion would be guaranteed to be true. Okay, quick illustration. All guinea pigs are fuzzy friends. All fuzzy friends are worthy of our respect. No creatures worthy of our respect should be mistreated, and therefore no guinea pig should be mistreated. You can break down this argument into its terms that represent its categories and the relationship among them. And I think if I'm not too confused, it would be something like this. All A are B, all B are C, no C are D, therefore no A are D. I think that's what the argument structure was. And once you break down the argument into its terms and the relationship among them, then you have a clear picture of the structure of the argument, and that's how you know whether it's, that's then when you can apply tests to see if the argument is valid. All right, this is too much review. Let's talk about categorical logic, very brief introduction, and especially a brief introduction to categorical propositions. So I've already talked about this, and well, I suppose this is true, but I shouldn't say couple. The first, in fact, all the methods we're going to use in this unit, that is to say the next, I don't know how many videos on categorical logic, will work on arguments using categorical logic. Well, here's another tiny piece of review. So far, we had our intro unit. Now we're doing our categorical logic unit. Next is going to be the statement logic unit, and then is the inductive logic unit. You could think of it this way. Introductory unit, deductive logic, and then inductive logic. In inductive logic, we're concerned with ways of figuring out whether the premises of an argument make their conclusion probable but not certain. In deductive logic, we're concerned with those tests for validity, with tests for knowing whether the premises of an argument make the conclusion 100% certain, assuming the premises are also true. And deductive logic has those two basic approaches, categorical logic and statement logic. So we have unit 1, intro, we just finished that. Unit 2, categorical logic, which is one branch of deductive logic. Unit 3, statement logic, another branch of deductive logic, and then we'll move to inductive logic. So right now, we're only interested in arguments that work by relating categories. So categorical logic is that branch of logic which is concerned with categories, classes, sets, or groups of things. The basic units of a categorical argument are its terms. Now, a term is, once again, the noun or noun phrase that stands for a category. A term is a noun or noun phrase that stands for a category. Since categorical logic is concerned with terms, since Aristotle did some categorical logic, since they talked about this a lot in the medieval era, categorical logic will sometimes be called term logic, or classical logic, or Aristotelian logic, or the Aristotelian system of logic or something. The name doesn't matter at all. They're all just different names for the same thing. I prefer the name categorical logic, but it really doesn't matter. What we're interested in understanding first is categorical propositions. Now, a categorical proposition is a proposition that relates to classes or categories. And categorical propositions come in 4 different forms. Actually, I shouldn't say standard. My notes here on the screen say standard. We'll worry about standard form probably in the next video. Categorical propositions come in 4 different forms, and those forms have names, A, E, I, and O. An A-form categorical proposition has the structure all S or P. An E-form categorical proposition has the structure no S or P, An I-form categorical proposition has the structure some S or P, and an O-form categorical proposition has the structure some S or not P. So let's illustrate it. All politicians are scoundrels. All teas have caffeine. All guinea pigs are fuzzy. And all days when it's raining are days when I should be careful. These are categorical propositions, and they're all in the all category. They're all saying something about every member of the first term mentioned in each proposition. And they're affirming something of that term, not denying it. The E-form propositions are things like no, no highlighters last forever. No staplers are perfect. This one's imperfect, but it works pretty well. I think I'd be able to come up with no propositions more easily. No Augustine books are boring. There, that's a good one. No Augustine books are boring. No staplers are perfect. And no highlighters last forever. And no caffeinated beverages should be drunk by me after 5 p.m. These are no form propositions. They're all saying something about everything that's in the category denoted by the first term. And they're also denying something to that category. I-form propositions are propositions like this. Some teas are teas I like. Some teas are caffeinated. Some protein snacks are snacks I like. Some pencils are red. Some pencils need to be sharpened. And some guinea pigs are pets. Those are some propositions. They say something about some, but they're not saying something about all members of the category denoted by the first term. They're affirming, not denying. So obviously the next one will be denying something of some, but not necessarily of all of the members of the category denoted by the first term, and that would be O-form proposition, some S or not P. Some highlighters are not very good anymore. Some pencils are not sharp. Some pencils are not blue. Some nerds do not speak fluent Italian. Some books on my shelf are not very expensive. Did I get all this right? I think I had not for all of those. An O-form proposition is a some S or not. It is a denial, not an affirmation, of some characteristic, actually of some category relation among the terms, among some members of the category denoted by the first term of the proposition, some S or not P. All right, enough of this, me trying to illustrate. Let's keep going, and then I think things will become clearer momentarily if they're not clear. Categorical propositions come in these 4 different forms. Note the structure of these forms when we put them into this standard form. Let me clarify that actually. Okay, let me, at the risk of some redundancy, let me say 2 things. First, all categorical propositions come in one of those 4 forms. They're either affirming something or denying something of the first term in each in any categorical proposition, and they're either affirming or denying something about all or merely about some members of the category denoted by the first term. So a categorical proposition is either universal or particular, and it's either affirmative or negative. So it's either universal affirmative or universal negative, or particular affirmative or particular negative. And universal affirmative is A, universal negative is E, particular affirmative is I, particular negative is O. Okay, so every categorical proposition has one of those 4 forms. Every single categorical proposition can be rephrased in a standard form using this language, all S or P, no S or P, some S or P, or some S or not P. I think I've talked too much again. I was going to say two things. I'll try to say them more succinctly. One, every categorical proposition in existence has one of those four structures: universal affirmative, universal negative, particular affirmative, or particular negative. At least every categorical proposition that relates to classes or categories. Every categorical proposition can accordingly be written out in a standard form. Since it's universal affirmative, you can phrase it in that all S or P, or since it's universal negative, you can phrase it in that no S or P form, or if it's particular affirmative, particular negative, you can phrase it in that that form, some S or P, some S or not P. And we need to do that so that we can test arguments for validity well. Again, I've talked too much. Let me try to say those two things again more succinctly. I think the third time I'll probably get it succinctly enough, and maybe we can keep scrolling down through our notes. Every categorical proposition in existence that relates to classes or categories is either universal affirmative, universal negative, particular affirmative, particular negative. In other words, every categorical proposition that relates to classes or categories is one of those four types of categorical proposition. Type is a good word. I should be using that for this first point. Every categorical proposition is one of these four types. And in order to test arguments for validity, we want to convert every categorical proposition, no matter how it's said in any argument, into a standard shape or a standard form, a standard structure, so that we can more easily figure out what is the structure of the argument. We want to get all of our categorical propositions into one of those four basic shapes in order to test our arguments for validity. Why? Because we need things to fit a standard form. Otherwise, we'll just have too many different rules. This is a normal thing in the study of logic. You have to do some work up front, shoving arguments and shoving propositions into a standard format, shoving them into a little box. And that's fine, because it doesn't change anything about the logic. In fact, the whole point of this is to understand the logic more clearly, to understand how the argument works better. But sometimes it seems unnatural, it seems robotic. We take things people say in ordinary language, and then we rephrase them the way a Vulcan or a computer might rephrase them. We rephrase them with some really rigid rules for phrasing things according to the standard forms. And every categorical proposition is going to have to be phrased as all are, or no are, or some are not. And that's the way it has to be. Why do we do this? Well, because we're paying up front with some extra work, shoving things into some standard forms, and we reap huge benefits later. I'm not using my metaphors well, am I? We invest up front some work putting categorical propositions, well, in general in logic, we invest some work up front putting statements and arguments into some standard forms, even in ways that are more like something a Vulcan or a robot would say, and less like ordinary human talk. But we get a huge benefit later. The investment pays off later when a very small number of strategies for testing arguments for validity will be applicable, because we only have four kinds of proposition to consider. This might become much clearer in the next video. Let's scroll down and hope it becomes clearer. Say something in comments if it's not clearer, if it's not clear enough. So a categorical proposition relates to classes or categories. They come in these four different types, and we write them out in the same four different forms, one form for each type. The universal affirmative form, all S or P, the universal negative form, no S or P, the particular affirmative form, some S or P, the particular negative form, some S or not P. These categorical propositions, once they're in standard form, have these components. We have a quantifier, a subject term, a copula, and a predicate term. The predicate term is the second category, the second term. The predicate term is the second term in the proposition. The subject term is the first term. The quantifier is the all, no, or some word. The copula is the are or are not. Some textbooks may allow is or is not. For example, they might let you say no S is a P. I don't like that. It's not enough work invested up front to save work later. If you're gonna allow some S, or if you're gonna allow people to say no S is a P and no SRP, things are gonna be weird. I recommend just sticking with plural R, because every term is supposed to be plural, so you need to have an R form for your copula. So the quantifier tells you whether it's particular or affirmative. All and no mean, sorry. The quantifier tells you whether it's particular or universal. All means universal, no means universal, some means particular. The copula, well, the copula usually tells you whether it's affirmative or negative. But here's actually one point where the logic textbooks generally strike a slightly different balance. Usually the logic textbooks have us pay a lot of work up front to save work later. We invest a lot of work up front in putting things into a very rigid standard form, our sentences and our arguments, our propositions and our arguments. We put them rigidly into a standard form with very narrow parameters. And we save a lot of effort later in not having a lot of rules or special methods or exceptions. Once we have things in standard form, we can apply a very small number of rules with no exceptions to our arguments to test them for validity. But there's one aspect of the standard approach. Let me just type it up for you here. There's one aspect of the standard approach that is a little bit non-consistent. If the E-form proposition, if the E-form type of proposition, if the universal negative type of proposition were put into standard form by saying all S are not P, then things would be a little clearer. Then the quantifier, all or some, would just tell you whether it's talking about all or some of the first term. And the copula, are or are not, would tell you whether it's affirmative or negative, and that's it. As it is, when we say no S or P, the quantifier always tells you whether it's universal or affirmative. And the copula tells you whether it's, what did I just say? The quantifier always tells you whether it's universal or particular, whether it's about all or just some. The copula usually tells you whether it's affirmative or negative, but not with the E form. When we say no S or P, the word no does double duty. It tells you whether the proposition is universal, and it tells you it is universal. It also tells you that it's negative, not affirmative. Now, why do we do that? Well, we do that because when people say all S are not P, sometimes they just mean some S are not P. Like if someone says all politicians are liars, and I, being optimistic enough to think there is such a thing as an honest politician, maybe they're a rarity, and far too many politicians, of course, are scum. I, if I'm careless, might say all politicians are not liars, and you know what I mean, right? I mean, not all politicians are liars. But what I've literally said is no politicians are liars. Also freaking Shakespeare and Tolkien. All that is gold does not glitter. Well, no, that's not true. Some things that are gold do glitter. So what you should say, Tolkien and Shakespeare, is not all that is gold does glitter. But I can't say that Shakespeare and Tolkien are not the masters of English language. They're not using logical precision here in their speech. They're using poetic speech, but we're hopefully smart enough to know they don't mean what they literally say here. All that is gold does not glister, I think is the phrasing in The Merchant of Venice by Shakespeare, and Bilbo's poem about Aragorn in The Fellowship of the Ring. All that is gold does not glitter, not all those who wander are lost. The old that is strong does not wither, deep roots are not reached by the frost, etc. This, all that is gold does not glitter, is literally telling us nothing that is gold glitters. But what it really means is some things that are gold do not glitter. So this is one case where the logic textbooks make a concession to ordinary human language because, frankly, too many logic students would get confused. And I hope not too many logic students are getting confused because I'm talking too much. That's, you know, it's a perennial temptation for me. So, no SRP is how we phrase, is how we make a standard. No SRP is the standard formula into which we want to put categorical propositions that are universal and negative, that say something about all, not just some, and that are denying category membership in the second category for the first category. In other words, statements like no teas or things I should drink after 5 p.m. and no staplers are perfect and no Augustine books are boring and no highlighters last forever. Statements like that we put into standard form as no SRP. And with that, the quantifier no tells you that it's negative, not affirmative, and it tells you it's universal, not particular. With all the others, the quantifier alone tells you that it is particular or universal, and the copula is what tells you whether it's affirmative or negative. For for A, I, and O form propositions, the copula tells you whether it's affirmative or negative. All right, so I've already told you this next thing that's on my notes, categorical propositions of quantity and quality. A and E are universal in quantity. I and O are particular in quantity. And in quality, which is a word we can use to describe whether it's affirmative or negative, in quality, A and I are affirmative, E and O are negative. And I've already told you this, next thing in my notes, the quantity is determined by the quantifier, the quality is determined by the copula, except for the E form proposition where the quantifier has double the work and tells you the quality as well as the quantity. And now let's deal with something that may have already been on your mind. What about a sentence like Confucius is a great philosopher? Isn't that a categorical statement? Well, yes, it certainly is. And note that it's affirmative. It's saying Confucius is a great philosopher. It's saying that category of people who are great philosophers is something Confucius is a member of. It's affirmative, not negative, which means it's an A or an I. And you're thinking because it's about just one, it must be an I, right? It's not all, it's only one. One means only some. No, it is all. It actually is universal because it's talking about the category of people who are Confucius. That means it's universal. It's talking about everyone who is Confucius. So it's an A form statement. Now we translate this into standard form as all people who are Confucius are great philosophers. That's it. The sentence Confucius is a great philosopher conveys the categorical proposition all people who are Confucius are great philosophers. So when you put it into standard form, you need to do it that way. All people who are Confucius are great philosophers. Let me pause the recording here long enough to close the window because it actually is raining and it's starting to make some noise. Oh, I have a meeting coming up soon. I gotta pick up the pace here. All right, where was I? Confucius is great philosopher is translated into the standard form for an A form proposition, universal affirmative, because it's affirming something of Confucius. It's affirming that he is in that category of great philosophers. And it's universal because it's talking about all Confuciuses. So the standard form is all people who are Confucius. And you might think this seems unnatural. Well, it kind of does. We don't normally do this. We normally refer to categories of one, like Confucius, which is a category of people who are Confucius, and there's only one of them, or anything else referring to a particular human being. Donald Trump has funny hair. All people who are Donald Trump are people who have funny hair, would be how you put that into standard form. We normally refer to categories of one by just saying the name of the thing in the category, particularly if it's a person. And we normally use an is, not an are, and so it seems unnatural. Well, as a concession to normal human speech, some logic textbooks will allow you, or at least some systems for doing categorical logic, or maybe I should say some strategies, will allow you to have a whole other set of categorical proposition standard forms. And say S is a P or S is not a P, where S is just a single person or some other category of one. My teacup, that's a single thing. My teacup is not purple. That is a concession to ordinary human speech. But the problem with that approach is if you're doing that, you're going to have to change all your strategies of checking an argument to see if it's valid later, because instead of just A, E, I, and O, you're going to have, I don't know, U and sometimes Y. I don't even remember. I think Hurley's logic textbook, let me think, what's the name of that book? I believe it's called A Concise Introduction to Logic. If I remember correctly, I think Hurley's textbook introduces this style. Maybe I'm completely forgetting, and maybe it was one of the other textbooks. Maybe it was Copy or Langdon. At least one of the standard logic textbooks does introduce this approach. I don't approve of this approach because it has a lot more work later, because you have to change all your methods of checking arguments for validity or come up with new methods for these kinds of things. But anyway, it is a thing that can be done. And for a simpler study of logic, I strongly recommend depart from ordinary human language just to this extent, that you translate sentences like Confucius is a great philosopher into sentences like all people who are Confucius are great philosophers. Translate any term referring to a category of one into a plural term, and make sure you translate the sentence as universal. My teacup is not purple would be translated as all things that are my teacup are things that are not purple, or better yet, no things that are my teacup are purple things. That would be the better way to do it. We'll do more of this in the next lesson. Anyway, it's another case of doing a little work up front to standardize things just a little bit and talk a little bit more like a logic teacher nerd or a robot or a Vulcan, and a little bit less like an ordinary human being. But the benefit is huge because it's so much easier to test our arguments for validity later if we do this stuff now. Observations on distribution. Let me think. Is this going to come up? Yes, I think this will come up in maybe our final method in this unit of testing arguments for validity. A term is distributed by categorical proposition when the proposition says something about every member of the class denoted by the term. And that means an A proposition distributes its S term because it says that all things denoted by the term members of the class denoted by the P term. In other words, if I say all cup noodles are salty, I'm distributing the term cup noodles because I'm saying that all of them are salty. I'm saying something about all members of the class denoted by the term cup noodles. An E proposition distributes both terms. If I say no cup noodles are caffeinated beverages. No cup noodles are caffeinated beverages. I'm saying something about all cup noodles. I'm saying they're not caffeinated beverages, but I'm also saying something about all caffeinated beverages. I'm saying none of them are cup noodles either. An I proposition does not distribute anything. If I say some teas are caffeinated, I'm not saying something about all teas or about all caffeinated beverages. An O proposition distributes the P term, but not the S term. If I say some cup noodles do not have a chicken flavor, I am saying that all things that have a chicken flavor are not those particular cup noodles. Some cup noodles do not have chicken flavor. Translated into standard form would be some, how do you translate cup noodles into standard form? Some cup noodle cups are not things that have a chicken flavor. I'm saying that those particular cup noodle cups, no things that have a chicken flavor are those. I'm saying something about all things that have a chicken flavor, that not even one of them is one of those particular noodle cups that I'm talking about. Okay, so the O proposition distributes the P term, but not the S term. All right. Actually, let's just skip that last bit I was going to talk about, and let's talk about the next bit. We don't need this last bit, and my brain gets all fuzzy when I try to talk about that because I've never used that in class. I don't keep much of that in my head. Let's delete that. Okay, so distribution actually completes our survey of the 4 forms of categorical proposition. There's the A form, which is universal and affirmative and distributes the S term only. There's the E form, which is universal negative, which distributes both terms. There's the I form, which is particular affirmative, which distributes no terms. And there's the O form, which is particular and negative and distributes the P term only. And actually, that's it. That's all we need to talk about. We'll do more later. We'll talk about Venn diagrams later, how you Venn diagram these propositions and so on. This should be sufficient. We'll talk more in the next video about translating categorical propositions from ordinary human language into standard form, which again is sometimes some real work, but we put in the work up front because it saves us a lot of work later, because it makes it a whole lot easier to test arguments for validity if we put everything into a standard form first.